There's an engine inside your chest that's more reliable than anything humans have ever built. It runs 24/7 for your whole life and never asks for a break. Today, we're going to put just one single beat of that engine, your heart, under the microscope. Let's pop the hood and see how it works. So, the first thing you've got to wrap your head around is that your heart isn't just one simple pump. Nope, it's way more sophisticated. It's actually a dual pump system, brilliantly engineered into a single organ, and it's running two totally separate blood routes at the exact same time. And here are those two jobs, side by side. On one side, you've got the pulmonary circuit. Think of this as the pit stop. Its only job is to take all that used, deoxygenated blood and shuttle it over to the lungs to get refueled with oxygen. Then, the other side of the heart takes over, with the systemic circuit, and its job is to pump all that fresh, oxygen-rich blood to literally every other cell in your body. Which, of course, leads to the big question, right? How on earth does this one organ pull off such a complex, perfectly timed dance without ever missing a single beat? For decades. Well, the only way to really understand it is to slow it way, way down. So what we're going to do is treat a single heartbeat like a short film. And we're going to break it down into a storyboard, a few key frames that tell the entire story from beginning to end. And look, this isn't just me trying to be clever with an analogy. It's a real technique. As this quote says, artists use storyboards all the time to make sense of really complex, fast-moving action. They freeze it into these manageable moments. We're just going to borrow their playbook and apply it to a little biology. So you see what I mean? Just like an artist would sketch out the key moments of motion to understand how it all works together, that is exactly what we are about to do for a heartbeat. We're going frame by frame.
Now, in the world of science, our little storyboard has an official name, the cardiac cycle. It's just the technical term for the complete story of one single heartbeat, from the moment it starts to the moment the very next one begins.
And here's the part that just blows my mind. This whole complex story we're about to break down, the squeeze, the refill, the sounds, the electrical signals, the whole shebang, it all happens in just 0.8 seconds. Yeah, less than 1 second. The efficiency is just staggering.
Okay, so let's get into it. Welcome to Act 1 of our story. I call this part the squeeze. The scientific name for it is systole, and believe me, it is all about generating some serious force. So here's our first frame of the storyboard. The main event of systole is right here. The big, muscular lower chambers of the heart, those are called the ventricles, they contract hard. It's a powerful squeeze that builds up immense pressure to launch that blood out into the arteries. And this chart tells the data story perfectly. Just follow the lines. See the light blue line? That's the volume of blood inside. As the muscle squeezes, boom, the volume drops. And what happens when you squeeze a fluid in a closed container? The pressure, that's the red line, absolutely skyrockets. That peak right there, that's what we measure as systolic blood pressure.
What's so cool is that we can actually hear and see this happening. You know that first heart sound, the lub? That is literally the sound of the valves between the upper and lower chambers slamming shut to prevent any backflow. And if you were hooked up to an ECG, you'd see this exact moment as that big, sharp electrical spike called the QRS complex.
Okay, but a pump is totally useless if it can't reload, right? So that brings us to Act 2, the refill. The scientific name is diastole. And let me tell you, this phase is every bit as important as the squeeze. This is when the heart gets ready for the next big push.
In this frame, everything just reverses. Those powerful ventricle muscles that were just squeezing, now they relax and expand. This change allows those atrioventricular valves to swing wide open, and the blood that's been waiting in the upper chambers, the atria, just flows right on down to refill the ventricles.
And if we look at our data story again, you can see it's the complete opposite of what happened before. As the muscle relaxes, the pressure, that's the red line, just plummets down towards zero. This creates something like a vacuum effect, which allows the volume, our light blue line, to shoot right back up as blood rushes in to fill the space.
And again, we can actually measure this phase too. That second heart sound, the dup, in lub, dup, that's the sound of another set of valves snapping shut, this time making sure none of the blood we just pumped out leaks back in. Electrically, on an ECG, this corresponds to the T wave, which is basically the signal that the ventricles are resetting for the next round. So we have this perfect sequence: squeeze, refill, squeeze, refill. It's like a flawless rhythm. But it makes you ask a pretty obvious question. Who's the conductor? What's directing this perfectly timed performance?
Well, the director is built right in. It's the heart's very own internal wiring, and it's called the cardiac conduction system. It's this incredible network of specialized cells that don't contract at all. Their only job is to generate and pass along electrical signals, telling all the other muscle cells exactly when to act.
Here's how it works, real quick. Step 1, the SA node, the heart's natural pacemaker, fires off a spark. Step 2, that signal zips across the upper chambers. Now step 3, and this is the genius part, the signal is intentionally delayed at a little checkpoint called the AV node. This pause is crucial. It gives the lower chambers just enough time to finish filling with blood before step 4, when the signal finally tells them to squeeze. It's just perfect time.
So if you remember one thing, make it this. The electrical signal is the script. It tells the heart what to do and exactly when to do it. The physical contraction, that whole squeeze and refill we've been storyboarding, that's the performance. The script always comes first.
Now, let's just zoom back out for a second to really appreciate the scale of this. This entire incredible 0.8-second story, this perfectly directed play of electricity, pressure, and sound, it repeats itself over 100,000 times, every single day. And you never even have to think about it.
Over an average lifetime, that's nearly 3 billion repetitions of this incredible 0.8-second story. It really makes you stop and wonder, doesn't it? What's the most remarkable, untold story your body is telling right now?